Continuity of piecewise functions. What is a continuous function? Some functions are continuous and others are not. Here are 3 examples of continuous functions. F, G, and H are all considered to be continuous. What is a discontinuous function? Some functions are not continuous, and here are 3 examples of functions that are not continuous. Capital F, capital G, and capital H are not continuous functions. They can also be considered discontinuous. So what makes a function continuous? Well, here's this function f that's continuous for all x in the domain. However, this piecewise function capital G is discontinuous at the 2 arguments of x equals -2 and x equals 2. The graph jumps in value at these 2 x values. So in order for a function to be continuous, you have to be able to sketch a graph on paper without lifting your pencil off of the paper. So f, we can clearly do that. We can just draw our parabola and have it be continuous the whole way. But here we can draw the line, but then we have to pick up our pencil or pen and go to the next point to draw this section. Then we got to pick it up again and then draw the final section. And that's what makes capital G discontinuous. The graph jumps. The function f appears to be not continuous at x equals 1. The graph that's shown here to the right has a jump at this x value of -1. So f of x is equal to this 2-section piecewise function. We have the quantity x plus 3 raised to the 2nd power, and then we're subtracting 4 from it. And that occurs if x is less than -1. The function is then equal to -2x plus k if x is greater than or equal to -1. So the right-hand piece of this function has this constant k as a part of the rule. And that means as k changes in value, the green ray will move up or down. If we slide this function, the hand cursor down, to make it continuous, where does it become continuous at? Right about here. The piecewise function f is not continuous at k equals 4. That will end up having its function value output be +6, and that's not 0. It's also not going to be continuous for k equals 1. If we have k equals 1, that would give us the y value of +3 when x is -1. It's still not touching our parabola section. However, the piecewise function does become continuous when k is equal to -2. When you have -2x minus 2, it will end up intersecting the parabola or meeting the parabola graph at the point -1, 0. So the desired k value is -2. We found out graphically that the k value that makes our function f continuous is -2. But how do we go about this algebraically? We actually do this by setting these 2 pieces equal to one another, because their outputs will end up being equivalent at x equals -1 in order for it to be continuous. So we will write out x plus 3 squared minus 4 is equal to -2x plus k. Since the boundary for these 2 rules occurs when x is -1, we're going to substitute -1 in for x on both sides of this equation. So we're going to have -1 plus 3 squared minus 4 is equal to -2 times -1 plus k. And now we can solve for k. When we evaluate this, we'll end up getting 2 squared, which is 4, and we'll have 4 minus 4 is equal to 2 plus k, and then 4 minus 4 is 0. 0 is equal to 2 plus k. So if we subtract 2 from both sides, we find out that k is equal to -2. So this is how we find that k value algebraically. And here's the solution to this example. and it does verify algebraically how the k value to make the function f continuous is -2. Let's try another exercise. We are given that g of x is equal to 3x plus b if x is less than 1, or that g of x is equal to -2 times b if x is greater than or equal to 1. What value of b makes g continuous for all x? Well, the first thing that we need to do is that we need to set both pieces of our piecewise function equal to one another. So that will be 3x plus b is equal to -2b. And we set them equal because where their outputs are the same, for the x value of 1 will make it a continuous function. And this x value of 1 is what we are going to substitute in for x. So we're going to have 3 times 1 plus b is equal to -2b. 3 times 1 is 3, and we can subtract b from both sides to give us -3 times b. And if we divide both sides by -3, our b value is going to be -1. And here's the solution. Again, we do set them equal to one another and substitute x equals 1 in for x and solve for b. And the solution is the same solution that we found, that b is equal to -1. Here's a final exercise, exercise C. We are given that h of x is equal to the piecewise function 3 minus k times x if x is less than 2, or x minus 4k if x is greater than or equal to 2. For what value of k makes h continuous for all x? Well, the first thing that we need to do is we need to take both pieces of our function and set them equal to one another. Because remember, where they are equal is that point of intersection, or point where they come together, that would make the entire function continuous. So we would have 3 minus k times x is equal to x minus 4k. And we're trying to find this value of k where the piecewise function, the first part ends and the second begins, and that's when x is equal to 2. So we're going to substitute 2 in for x and then solve for k. So we have 3 minus k times 2 is equal to 2 minus 4k. So we can simplify this a little bit. 3 minus 2k is equal to 2 minus 4k. If we add 4k to both sides, we'll end up having 2k on the left, and if we subtract 3 from both sides, we would end up having -1 on the right. And then if we divide both sides by 2, we'll get that our k value is equal to -1/2. And below is the solution to this exercise. It does come out to be the same value of k, -1/2, that we found when we solved it.